Hello everyone. In this lecture, I will discuss about the how to solve the linear programming problem by graphical method of extreme or corner point approach method. Let's see the problem. Solve the following linear programming problem using graphical method. Maximize z equal to 6x1 plus x2 subjected to constraints 2x1 plus x2 greater than or equal to 3, x1 minus x2 greater than or equal to 0, x1, x2 are greater than or equal to the 0. Here objective function is maximize z equal to 6x1 plus x2 and x1, x2 are the decision variables and the constraints are 2x1 plus x2 greater than or equal to 3, x1 minus x2 greater than or equal to 0 and x1 or x2 greater than or equal to 0 are the non-negativity constraints. This problem is given in September 2021 for 3rd BTech first sem in JNTU Hyderabad. Let's see the solution. First step is we have to consider the each inequality constraint as an equation. For this, replace the inequality by equality. Then our constraints are 2x1 plus x2 equal to 3. Let us consider this is the equation 1. Second constraint is x1 minus x2 is greater than or equal to 0. Then it will become x1 minus x2 equal to 0. Let us consider this is the equation 2 and x1 and x2 are greater than or equal to the 0. Second step is each constraint will be plotted on the graph by treating it as linear equation. So first constraint equation is 2x1 plus x2 equal to 3. For this, first we have to find the coordinates for this equation. Let us assume x1 equal to 0 and substitute in above equation, x2 will become the 3. Similarly, if x2 equal to 0 and substitute in above equation, then x1 equal to 3 by 2 and x1 value is the 1.5. So coordinates for this constraint equation is 0, 3 and 1.5, 0. Similarly, second constraint equation is x1 minus x2 equal to 0 and x1 equal to 0. If x1 equal to 0, x2 value also 0. Similarly, if x1 equal to 4, x2 value also 4. So coordinates for this constraint equation is 0, 0 and 4, 4. So next step is we have to draw the horizontal and vertical axis here. X1 is horizontal axis and x2 is vertical axis. And observe the highest values for the x1 and x2. Here observe that one 4, 4 are the highest values for the x1 and x2 decision variables. So mark the 1 centimeter equal to 1 unit on the graph sheet and make up to the 4 units in x1 and x2 axis. This should be like this. So next we have to mark the coordinates of the constraint equation on the graph sheet. So that is for the first constraint equation 0, 3 and 1.5, 0. So first we have to mark the 0, 3 point. So this is here. And we have to mark the 1.5, 0 point. So that is the approximately it will become here. Then we have to join these 2 points. It gives the first constraint equation line. Similarly, for second constraint equation, first we have to mark the 0, 0 point here and also have to mark the 4, 4 point. 4 and 4. So this is approximately here. And we have to join these 2 points. So it will be give the second constraint equation. First step is mark the feasible region based on inequality conditions of the constraints. First constraint is 2x1 plus x2 greater than or equal to 3. Here inequality is greater than or equal to. Then we have to consider the region above the constraint line. So this is the region for the first constraint line. Second constraint is x1 minus x2 greater than or equal to 0. It is x1 is greater than or equal to the x2. See here, if x2 equal to 1, x1 will become 1 or greater than the 1. Similarly, if x2 equal to 2, x1 value is the greater than the 2 or maybe 2. So we have to consider the region above the constraint line. So this is the region for the second constraint line. So next we have to find the feasible region. So feasible region is the area which is bounded by all the constraint lines, which means common area bounded for all the constraints. Here this is the feasible region, and also have to observe here this feasible region having the infinite area. So it is having the infinite area. So objective function are permitted to increase infinitely without violating the feasibility condition. Then solution of the given objective function is said to be unbounded. So this is the solution. So thank you.